Hello, I am Reagan Logier coming in from the machine shop of the training ship Golden Bear, and I'm going to be going over and describing the function and operation of a simple DC motor. Over here on the workbench, I have a simple DC motor that I have made. Right here is a circuit diagram for this simple DC motor. Feel free to pause the video to take a glance at it. This simple DC motor consists of a 6-volt DC power supply, an H-bridge that allows me to control the polarity of this DC power supply, LEDs that indicate the direction of the polarity, a coil consisting of magnet wire and 2 metal posts, as well as stripping of the magnet wire, hard to see in the video, but partial stripping of the magnet wire that allows it to function as a commutator, and a decently strong permanent magnet right underneath of the coils. Now we'll be getting into the function of a DC motor. We're first going to take a glance at positive polarity on this DC motor. So looking at this quick little circuit diagram, when we give this, feel free to pause the video to take a glance if you'd like. When we give this motor positive polarity, this post becomes positive, this post becomes negative. Taking a glance at this circuit diagram describing the current, flux, and force, we always have a magnetic flux coming straight off of the table. That is our magnetic flux coming straight up off of the table. In the case of positive polarity, we have a current flowing from right to left on the top of the coil and from left to right on the bottom of the coil. That is right to left on the top of the coil and left to right on the bottom of the coil. Based on Lorentz force, this current and magnetic flux is going to exert a force going away from the camera on the top of the coil and towards the camera on the bottom of the coil. That's going to cause our motor to rotate away from the camera on the top just like that. To demonstrate, I need to give the motor a little push. I'm now going to apply power, and if we look, the motor's spinning nice and strong, nice and continuous with our applied power. This is the theory at work. We're now going to go ahead and take a glance at reverse polarity. I'm going to use reverse polarity to actually slow this motor down. There we go. So to take a glance at reverse polarity, we're again going to pull up a similar diagram. However, in reverse polarity, our left post on the motor becomes positive and our right post on the motor becomes negative. We again have the same magnetic flux coming straight up off of the table. However, now our current on the top of the coil is flowing from left to right, and our current on the bottom of the coil is flowing from right to left. So that is current on the top flowing left to right, current on the bottom flowing right to left. So opposite of before. Based on Lorentz force, we now have a force exerted on the top of the coil towards the camera and a force exerted on the bottom of the coil away from the camera. This is going to cause our motor to want to rotate in this direction. So I'm going to give it a little push. That this direction is the top of the coil spinning towards the motor. Just going to give it a little push. Going to apply reverse polarity. And we have the motor spinning up nice and strong. It's hard to see, but the camera's not picking up. It's actually sparking. Yeah, this is a nice demonstration of a simple DC motor. Thank you for watching. Hope you enjoyed.